name is Alan. This video is about the fundamental concepts surrounding AWS and the IAM system. I hope I'm able to teach you something new, or at least inspire you to continue learning. IAM stands for Identity and Access Management. The IAM system within AWS takes care of identity authentication and identity authorization. Note, there are some key differences between authentication and authorization. Authentication refers to proving the identity assumed by someone is either true or false, while authorization refers to the level of clearance or access that an identity has. But you may be unfamiliar with these concepts. You may ask questions like, what exactly is an identity? How exactly is access managed? And those are the fundamental questions we're going to answer today in this video. Let's answer the first question. What's an identity? An identity, also known as a principal, is an entity within the IAM system, capable of obtaining a level of authorization and credentials to enable its use of different apps and services. An identity can have a set of rules attached to them, granting them each varying levels of access. These set of rules are defined using a policy. We will get more in depth on policies, but first let's go over the main types of identities and their use cases within the IAM system. There are multiple abstractions of identities used within the IAM system, but most important ones are IAM users, IAM roles, IAM groups, IAM federated identities, and identity providers. The first identity we're going to discuss is the IAM user. An IAM user is a human or workload that can be granted authority or permission to use a service. For example, let's say we have a developer named Mike who wants to use the Elastic Kubernetes service within our AWS infrastructure. However, he does not have the proper permissions or even a user to access the EKS service in the first place. To help our friend Mike, we can create him an IAM user and give him the appropriate credentials so that he can log in into the user and attach to his user a policy, granting him the proper level of access to manage that service. You can think of an IAM role as an identity class that can be assumed. IAM roles contain a set of policies that can be inherited. These policies are inherited when you assume the role. Now let's circle back to the useful developer called Mike and the IAM user we created for him. We want the user to keep the previous set of permissions that we've given him, but also allow him to inherit another set of permissions so that he can access an S3 bucket in our infrastructure. However, our use case doesn't want Mike to always have an access to the S3 bucket service, only for a small period of time. We want this same behavior to apply for the rest of the team who wants to use the S3 bucket. This is where an IAM role can flourish. We can create an IAM role and then attach to it a set of policies that enables it to manage and interact with the S3 bucket service. Assuming that Mike is already included in the role's trust policy, our developer Mike can temporarily assume the role, inheriting the policies of the role, giving them access to the S3 bucket. An IAM group is a classification or categorization of a collection of IAM identities. They can share a set of rules or permissions. Let's say that we had a team of 3 or more talented engineers, Bob, Millie, and Mike. They all are working on a group project together that requires each of them to have access to an EC2 instance within their infrastructure. But we also want to preserve the permissions and policies that we have previously given them. Rather than the cumbersome approach of attaching the policy to each identity individually, you can create an IAM group and add their users to the IAM group and attach a policy to the group instead. This in turn allows them to share a set of permissions. This is also very useful for future-proofing. In the event that you want to grant the same group of identities even more permissions, you can do this in a centralized identity, speeding up the process of access management. An identity provider is a user or workload outside the AWS jurisdiction. For this example, we have a CI/CD pipeline that interacts with our infrastructure to automate the deployment of newly made source code by our engineers and send them to the applications running in our containers hosted on the cloud. You can create a federated identity for a GitHub Actions worker to programmatically use OpenID Connect for the authentication process, assume a dedicated IAM role with the appropriate permissions to interact with our services. Although all of these identities have their own use cases, they all share one thing in common. They are all used to authenticate and authorize our interactions with the AWS infrastructure. So now that we know that an identity is an entity within the IAM system capable of obtaining a level of authorization, and that there are different abstractions of these identities, there's still a question. How exactly do policies provide the IAM identities the required permissions? Policies in the simplest form can be expressed as a protocol or set of rules to be followed. For example, in an office environment, there are policies for different things such as unexpected weather, worker compensation, etc. There are also policies in AWS. AWS offers a wide variety of policies. The use cases can be outside of authentication. For example, ECR service uses what is known as an image lifecycle policy. The image lifecycle policy is a set of rules regarding the management of container images. One thing in common with these policies is that they're typically formatted as a JSON file, including the policies that the IAM protocol uses to function. The IAM protocol uses identity-based policies, resource-based policies, and trust policies. The identity-based policy is a set of rules to be followed. It's a definition of the available permissions of an identity written in a JSON format. In other words, this is one of the methods in which an identity can get their permission. They are defined inside an identity policy, and the identity policy is attached to them. While a resource-based policy is a policy attached to a resource, it can define the identities capable of accessing the resource or the permissions required to access the resource. A trust policy is usually attached to a role. It is typically used to define what identities can assume the role. So we have an IAM policy, which we now know is a set of rules regarding the permissions given to an identity or a resource. As mentioned before, we have an identity-based policy and a resource-based policy. Now they're both policies, of course. They both are written in JSON, and they both grant and deny permissions. The only difference being is that the identity-based policy is attached to an identity and does not require a principal. This is because the principal is implied to be the identity that is attached to the policy. Now, for the resource-based policy, instead of an identity, it is attached to a resource, and this does require a principal. This is because the resource-based policy does not have a method to imply the identity that is being denied, because we have no reference. So because we have these two policies, one for the IAM identity and another for the resource, this can actually open a door for multi-factor behavior regarding the ability to access a resource. For instance, if the identity policy of a user authorizes the use of a service, while the resource-based policy denies that user explicitly, the policies contradict, blocking the user from ever accessing that resource. All of these policies are written in JSON, and the JSON file itself is made up of elements. Elements are the building blocks of the policy. They contain the data that make up the JSON policy. There are important elements that are used by both the identity and trust policies. We have the version, the statement, SID, effect, action, principle, resource, and condition. The version element is basically just the version of the policy language. The statement is essentially a wrapper for all the other policy elements. The statement allows us to organize the rest of the elements. You can have multiple statements in one policy. The SID stands for Statement ID. It's an optional ID for referencing the statement. The effect. So every policy can either deny or allow a specific identity from doing a specific action, which is our next element. The action element just defines the actions that we are allowing or denying to be done on that resource. Now, the policy needs to know who exactly is getting either approved or denied for these actions, and that is defined in the principal, our next element. The principal element is used to define the identities the policy applies to. The resource element is used to define the resource in which the actions can take effect. And lastly, we have the condition element. The condition element is used to add conditional criteria for the policy's functionality. For example, One condition could be multi-factor authentication. We can actually define whether or not we want to allow or deny the access to a certain resource based on whether or not the multi-factor authentication feature is enabled on the principle that is mentioned on this policy.